Hello, welcome to the Bureau of Economic Geology's Austin Earth Science Zoomerama. Today we will hear from Tiffany Caudle, a coastal geologist with the Bureau of Economic Geology. In today's talk, Tiffany will tell us about one of the most powerful natural hazards, hurricanes and the Texas coast. Tiffany, thank you so much for joining us today. The floor is yours.
Thank you, Linda, and thank you to all the students and teachers who are joining us today for our discussion about hurricanes and the impacts on the Texas coastal environment. My name is Tiffany Caudle, and I'm a coastal geologist who's been working at the Bureau of Economic Geology, part of the Jackson School of Geosciences at the University of Texas at Austin for the past 20 years. My primary research at the Bureau includes conducting studies of monitoring shoreline change along Texas's bays and the Gulf of Mexico shoreline, studying storm impacts to the coastal environment and beach and dune recovery post-storm, and also being the coordinator and the principal investigator for the Texas High School Coastal Monitoring Program. The THSCMP works with middle and high school students at 8 coastal school districts collecting critical beach data for the state of Texas. Today we're going to be talking about hurricanes and how they impact coastal environments. We'll discuss what is a hurricane, how they are classified, where they form and how they are named, and also the hazards that are created for coastal environments. We will then look at a few storms that have made landfall on the Texas coast, including the Great Storm of 1900 that devastated Galveston. So what is a hurricane? A hurricane is a tropical cyclone. Tropical cyclones are massive storms with extremely strong winds that spiral around a center of low air pressure. These storms form over warm ocean waters around the world. A hurricane typically has a circular shape and an average diameter of about 300 miles. The storms are made up of many bands of thunderstorms that spiral outward from a central eye. Tropical cyclones are variously named in different parts of the world. Those that form in the Atlantic Ocean and the Eastern Pacific are called hurricanes. Those that form in the Western Pacific Ocean are called typhoons, and those that form in the Indian Ocean and the Southern Pacific Ocean are called cyclones. In the Northern Hemisphere, tropical cyclones rotate counterclockwise, whereas in the Southern Hemisphere, they rotate in a clockwise direction. The spiraling of the winds is produced by Earth's rotation, and this phenomenon is known as the Coriolis effect. A mature hurricane is nearly circular in shape. A hurricane can be broken down into the 3 main parts, the eye wall, and the outer rain bands. In mature hurricanes, strong surface winds move inward towards the center of the storm and encircle a column of relatively calm air. This nearly cloud-free area of light winds is called the eye of the hurricane and is generally 12 to 13 miles in the diameter. The center of the hurricane has the lowest atmospheric pressure in the storm. Scientists measure the air pressure in the eye to understand and forecast how strong the storm will be. Air in the center of the eye slowly sinks from above, becoming warmer and drier as it sinks. Surrounding the eye is a violent stormy eye wall formed as inward moving warm air turns upward into the storm. The strongest winds and heaviest rainfall are found in this wall of clouds and is usually considered the most deadly part of the hurricane. Outside the eye wall of a hurricane, rain bands are regions of heavy thunderstorms that spiral outward from the center of the storm. These rain bands are capable of producing heavy rain and wind and occasionally tornadoes. Sometimes there are gaps between the bands where no rain is found. In the Northern Hemisphere, winds on the right side of the hurricane, with respect to the path of the hurricane, are usually stronger than winds on the left side of the storm. The strongest winds occur on the right side because in this region, the horizontal winds that blow the storm forward are combining with counterclockwise whirling winds within the storm. Hurricane classification. Hurricanes come in different sizes and intensity and move at different speeds, all of which determine the impact on the environment. A small, fast-moving, higher intensity hurricane may have less impact than a large, slow-moving, lower intensity storm. We classify tropical cyclones based upon their maximum wind speed using the Saffir-Simpson hurricane scale. When winds are less than 39 miles per hour, we call those storms tropical depressions. Winds speeds of 39 to 73 miles per hour are classified as tropical storms, and that's when the storm is named. And greater than 74 miles per hour, a storm becomes a hurricane. Hurricanes in the categories of 3, 4, or 5 are known as major hurricanes. So each hurricane designation within the Saffir-Simpson scale is based upon a range of wind speeds, and from those wind speeds, we can also estimate what the storm surge might be for these storms. Where do tropical cyclones form? They form in the warm waters of the tropics and subtropics. They can form as tropical waves off the coast of Africa and travel west across the Atlantic Ocean, or they can form in the Caribbean Sea or Gulf of Mexico. The warm waters of these regions are favorable for the development of this type of storm. The graphic shown on the screen is all the known tropical cyclone tracks in the North Pacific Ocean from 1949 to 2017, and in the North Atlantic Basin from 1851 to 2017. The yellow lines are tropical storms. The red lines are tracks for Category 1 and Category 2 hurricanes. And the purple lines are major hurricanes. These are storms that are Category 3 or above. We started naming tropical cyclones in the 1950s, so 1953, using only female names. Prior to that, storms were designated by the year in which they made impact. But after there was more storms during each year, and they needed a way to designate the names of these storms so that we could keep them straight in years going forward. In 1979, the National Weather Service and National Hurricane Center started using an alternating list of male and female names. The letters Q, U, X, Y, and Z are not included in these lists because there's a scarcity of names that begin with those letters. So each year there's a list of 21 names, and there's a list for 6 years of what the hurricane names will be. So and then they were recycled. So the list for 2020 will be reused in 2026. If there's a storm season that has more than 21 storms, then we start using the Greek alphabet. In 2020, this year, we have already used Alpha, Beta, Gamma, Delta, Epsilon, and Hurricane Zeta just made impact on the Louisiana coast yesterday. The only other year the Greek letters have been used was in 2005. That hurricane season ended with Tropical Storm Zeta that formed on December 30th of that year. Sometimes names of storms are retired if a storm has been particularly deadly or costly, and it would be inappropriate to use that name again in future years. For example, Hurricanes Katrina and Rita, those names were retired after the 2005 season, Ike after 2008, and Harvey in 2017. The official Atlantic Basin hurricane season runs from June 1st to November 30th. Now, that doesn't mean that storms can't form outside of those dates. This is just what is considered the official hurricane season. On average, 12 tropical storms, 6 of which become hurricanes, form over the Atlantic Ocean, Caribbean Sea, or Gulf of Mexico during the hurricane season. 2 of those storms will become a Category 3 or greater. Now, this is just on average. 2020 has been an extremely active hurricane season. For example, typically only 1 or 2 named storms form prior to August. In July, 5 tropical storms, including 2 which became hurricanes, formed in the basin. The 5 named storms tied the record for the most named storms forming during the month of July, which was previously set in July 2005. The peak of hurricane season is during the month of September. Over a 30-year average, September typically has 4 named storms. 3 become hurricanes, 1 of which will become a major hurricane. Again, September 2020 has set a record for most named storms in a month, with 10 forming. 4 of those storms, Nana, Paulette, Sally, and Teddy, became hurricanes, with Teddy reaching major hurricane strength. In an average 3-year period, roughly 5 hurricanes will strike the United States coastline, of which 2 are typically major hurricanes. That means wind speeds greater than 110 miles per hour. What are some of the hazards that are posed by hurricanes? First of all, the wind. As we talked about earlier, the hurricanes, tropical storms, are designated based upon their wind speed in that eye wall. Tropical storm and hurricane force winds can destroy buildings, infrastructure, and vegetation, including trees and plants that are outside. The debris that is blown over from these hurricanes, including items that may have been left outside, can become flying hazards during a hurricane. Tornadoes often occur in the thunderstorms in the outer rain bands. They can also occur near the eye wall. They're often short-lived, but they can be a dangerous part of the hurricane. Rainfall is another major hurricane hazard. Tropical cyclones can produce widespread and torrential rains that can result in deadly and destructive floods. This is not only an issue along the coastal zone, but is also a serious threat for inland flooding, where rivers can overflow their banks and flood the areas surrounding them. Waves and rip currents. Hurricanes are known for producing strong winds that create large and dangerous waves that cause extensive erosion to the beach and the dune system, and also damaging infrastructure along the shoreline. When the waves break on the shoreline, they can produce strong rip currents. Rip currents are channeled currents of water flowing away from the shore. These currents can pull objects in the water, including humans, back out into the ocean and causing them to drown. The other major hazard during a hurricane is called storm surge. And when storms are forecasted, a lot of times a storm surge prediction is also included with the wind speed forecasts that are given. This storm surge is a rush of water that is driven on shore by the storm's powerful winds. During a hurricane, one of the greatest threats of life and property is the storm surge. As hurricanes move toward land, they push a mass of water in front of them. And when this wall of water reaches land, it can have very destructive and often deadly consequences. As the wind speeds increase, water within the surge can build to a height above the structures that are on the land. So the storm surge is this rise of water that's produced by water being pushed towards the shore by the force of the winds. This is measured as the height of the water above the normal predicted astronomical tide. A storm tide is the total observed seawater level during a storm. This results from the combination of the storm surge plus the astronomical tide. The highest storm tides are often observed when landfall of the hurricane coincides with a new or full moon. This is called a spring tide. This is when we have our highest tides during the lunar cycle. In addition to the storm tide and the storm surge, we have the wind-driven waves. These are on top of the water level that is increased due to the storm surge. Let's watch a quick video on storm surge.
One of the most dangerous parts of a hurricane is storm surge. What is storm surge, you ask? Storm surge is what happens when the winds of a coastal storm push water onto land. In addition, large and destructive waves ride in on the top of the surge. These water surges then wreak havoc and can cause major damage and flooding many miles from the storm. Not limited to coastal properties, storm surges from seawater traveling up streams and rivers can flood inland homes too. And is it strong? Able to carry away cars and demolish entire communities. It doesn't take extreme wind to make storm surge happen. Low-end hurricane winds from Sandy created a storm surge that leveled parts of New York and New Jersey in 2012. Storm surge is what officials use when determining who to evacuate. Once water starts to rise, the destructive rush can quickly cover a lot of ground: homes, cars, people, pets. If you get anything from this video, let it be this. When officials say it is time to evacuate, go. Don't fall victim to storm surge.
Emergency managers remind people to run from the water and hide from the wind. This means if you live in low-lying coastal environment or a flood-prone area in the projected path of a hurricane, evacuate to higher ground and then stay indoors when a hurricane is over top of you. So why is it important to understand hurricanes when studying the Texas coast? It's because they have impacts on the Texas coast to the environments that lie along this low-lying area. Along the entire Texas coast, we have what are called barrier islands. These are long, narrow islands parallel to the coast that are built up by the deposition of sand. There's usually an estuary behind the island, which separates the barrier island from the mainland. The purpose of barrier islands is to protect the mainland and the estuary from large waves and storm surge that is associated with hurricanes. Along the Texas coast, we have 367 miles of Gulf shoreline. Under normal day-to-day action, or under normal day-to-day activity on barrier islands, we have standard processes that are occurring. These include normal waves, the longshore drift, which carries sediment along the barrier islands, wind actions, constantly moving sediments around on the barrier islands, rearranging the features like the back beach and the dunes. But then we also have these storm events, storms such as hurricanes that cause abrupt changes and drastically impact the barrier islands, sometimes destroying parts of the island, but also creating new features through the action of wind and water. And as a coastal geologist, this is what we are looking at after the passage of a hurricane. How have these barrier islands, how have the beaches and dunes been changed, and also the entire barrier island been changed from the impact of a storm? These pictures in these slides, on the left-hand side is Galveston Island State Park in April of 2008. We had a wide beach with a nice dune line, picnic shelters resting behind the dune line. But after the passage of Hurricane Ike, which occurred in September of 2008, the dune system was destroyed and sand was carried across the island, covering the picnic area and a lot of the infrastructure at Galveston Island State Park. A feature that is often formed during hurricanes are washover channels and fans. A washover channel is a storm-generated channel that erodes the beach and dunes and connects the ocean sometimes directly to the lagoon or estuary behind. After the storm passes, normal day-to-day longshore current and waves will oftentimes refill these sediment channels at the mouth where it opens into the Gulf of Mexico. But other times, if the currents flowing through the channel are strong enough, the channel may remain open. A washover fan is a fan-shaped deposit of sediment that is on the landward portion of the barrier island, and this is created by the storm action. While the storm is eroding the dunes and the beach and creating that channel through the island, that sediment that has been eroded from the beach and dunes is deposited on the backside of the island, creating a fan-shaped feature. You can see the sediment deposit in the picture on the left. This was a hurricane washover channel that formed due to Hurricane Allen in 1980 on Mustang Island. This is Corpus Christi Pass. So the Gulf of Mexico is at the bottom portion of the photo, and the storm created a channel that cut through from the Gulf of Mexico into Corpus Christi Bay and the backside of this image. And that fan-shaped deposit on the backside is the sediment that was eroded from the beach and dunes, carried through the channel and deposited on the backside of the island. Now, this is a destructive process, but also a constructive process, because that fan over time will accumulate more sand and sediment that's being blown from the dunes back to the backside of the island. And vegetation can take root on those fan-shaped deposits, creating a larger island on the backside. Now the Corpus Christi Pass on Mustang Island is closed across the front of the Gulf of Mexico. Their dunes have reformed. They're not as large as the dunes on either side, but there is a dune field and across where the channel formed. And that fan-shaped deposit on the backside of the island is covered with vegetation. So it is a way of growing the island on the backside, moving the island landward. So even though it's destructive and creating this channel cutting through the island, it can also be a constructive process. It's a way to quickly gain sediment on the backside of the island. We're going to watch a quick video. This is a Google Earth time lapse of Fire Island, New York. It starts, I believe, in the 1980s and runs through 2016. But what I want you to notice in this central part of the image is the barrier island is complete. You can see the beach. There's a low dune ridge along the island where this breach will form. And you can start to see small washover features. They don't go all the way into the sound that is behind Fire Island over time, but then Hurricane Sandy in 2011 created this breach in the barrier island. Now we're going to start talking about some hurricanes that have made impact on the Texas coast, specifically on the Texas coast. And the first one we need to talk about is the hurricane of 1900 that impacted Galveston Island. Galveston Island is a 27-mile-long barrier island that protects the Texas mainland from that hosts many important cities and ports, including Houston. In early September of 1900, Galveston was a very busy city. It had a booming economy, and it was the busiest seaport in the state. At that time, the city of Galveston was the fourth largest city in the state and was called the Jewel of Texas. On the morning of September 8th, this was a Saturday, 1900, it was a little dreary and windy when folks woke up that morning. And the 37,000 people who lived on the island, they just went about their normal business that morning. The Galvestonians that lived there, they weren't even concerned that tides were a little bit higher than normal that morning, because street flooding was a common occurrence on Galveston Island, since the island was only about 9 feet above the normal ordinary high tide line. They knew that there was a tropical storm in the Gulf of Mexico, but they had no idea how strong the storm was or that it was heading right towards the island. By the time the residents realized how bad the storm was becoming, it was too late for many of them to seek shelter or evacuate. As the wind and storm surge increased throughout the day, the first line of buildings along the shore were destroyed. And then the storm waves pushed that debris from one row of buildings into the next. So multiple lines of homes along Galveston Island were destroyed during this storm. The storm surge that was estimated during the hurricane of 1900 was about 15 feet, above 15 feet. And remember, the highest elevation on the island at that time was only 9 feet above ordinary high tide line. During this storm, it's estimated that about 6,000 people in Galveston died, although the real numbers are believed to be much higher. 36,000 buildings were destroyed, and the damage is estimated about 25 million at the time. This is about $700 million in today's dollars. And even though there's been stronger and costlier hurricanes to strike the United States coastal areas, the 1900 storm that struck Galveston Island is still the deadliest natural disaster to ever strike the United States coast. After the 1900 storm, the city decided to rebuild. The survivors of the city decided to rebuild, and they built a seawall along Galveston Island. It was started in 1902. It's 16 feet high, and the seawall today extends for approximately 10 miles, or nearly 1/3 of the Galveston Gulf of Mexico shoreline. This seawall has protected the city numerous times from the threat of tropical storms and hurricanes. The elevation grade, or landward of the seawall, the elevation grade of the city was also raised. Sand was pumped from the Gulf and ship channels and placed behind the new seawall, raising the elevation of the land. Directly behind the seawall, the land was raised almost 11 feet and slopes down towards the bay. This required raising 500 city blocks or buildings, including a 3,000-ton church. But not only were the buildings raised to a higher elevation during this project, but all city public services needed to be raised as well. This included the gas lines, the water lines, sewer lines, roads, streets, streetcar tracks, sidewalks, fences, light poles. The city paid for the public utilities, but if a homeowner wanted to raise their house, they had to pay for that own expense. And homeowners wishing to save their plants and trees also needed to remove those plants and have them replanted after the property was raised. The raising of an entire city and building the protective seawall was a remarkable engineering feat at the turn of the 20th century. During the last 30 years, from 1990 to 2020, there have been 10 hurricanes that have struck the Texas coast and 15 tropical storms. That averages to about 3 hurricanes per decade and 5 tropical storms per decade. I have highlighted here, or here's the list of all the tropical storms or hurricanes that have struck the Texas coast or made landfall near the Texas border between 1990 and 2020. Highlighted in red are major hurricanes that have struck the coast. Just in the 2020 season alone, we have had 4 hurricanes that have had impact on the Texas coast. First being Hurricane Hannah that made landfall on Padre Island as a Category 1 storm. Hurricane Laura made landfall on the Texas-Louisiana border as a Category 4 hurricane. Tropical Storm Beta, which made landfall on Matagorda Peninsula. And then most recently, Hurricane Delta was a Category 2 near that Texas-Louisiana border. And we're going to look at the impacts of Hurricane Ike, which struck Galveston Island in 2008, and Hurricane Harvey that struck the Texas coast twice in 2017. Hurricane Ike made landfall as a Category 2 storm on the southern end of Bolivar Peninsula on September 13th, 2008. At the time of landfall, maximum sustained winds were over 100 miles per hour. Ike reached Category 4 status while it was still over the Atlantic Ocean. This storm formed in the Atlantic Basin and traveled across the Caribbean, came into the Gulf of Mexico, and then turned to make landfall on Bolivar Peninsula. The storm surge associated with this storm when it made landfall was estimated at 15 to 20 feet on Bolivar Peninsula. Bolivar Peninsula is just to the northeast of Galveston Island. Prior to Hurricane Ike's landfall near Galveston Island, at the state park that is on the island, they had a wide beach and healthy vegetated dunes. Data collected by scientists and students that participate in the Texas High School Coastal Monitoring Program allowed scientists to determine that the shoreline at this point moved 174 feet landward due to the impacts of this storm. And also the pre-storm datum, the point from which we monitored Galveston Island State Park was located almost 4 feet above the post-storm level of the beach. That means all of that sand and sediment was removed from the beach when the shoreline moved seaward, and that sediment was deposited on the backside of the island, creating a small washover feature that covered the infrastructure at the state park and also into a small lagoon that was behind there. The dune system at this Galveston Island State Park were completely destroyed by Hurricane Ike. The beach and the dune system have recovered at Galveston Island State Park. There is a mature dune system that is there now. It is landward from the original position of the dune line prior to Ike's landfall, but a nice wide beach has formed, and there's coppice dunes, meaning that there's a lot of sediment being added to the system and that the beach is growing over time. Additional storm impacts from Ike included washover features on Bolivar Peninsula due to the storm surge. And also on Bolivar Peninsula and Galveston Island, they both experienced significant beach and dune erosion and extensive damage to property and infrastructure due to the hurricane. In 2017, Hurricane Harvey started as a weak tropical depression in the Atlantic Ocean. Between August 17th to August 19th, it traveled across the Lesser Antilles Islands as a tropical storm and then dissipated over the Caribbean Sea. The tropical wave that had been Harvey continued to cross the Caribbean Sea and the Yucatan Peninsula and then re-intensified in the southern Gulf of Mexico. Harvey rapidly intensified between August 23rd and August 25th when it made landfall on the middle Texas coast. The storm then stalled along the Texas coast retaining a tropical storm strength, centering along the Texas coast for about 4 days, dropping historic amounts of rainfall of more than 60 inches over southeastern Texas. These rains caused catastrophic flooding, and Harvey is the second most costly hurricane in U.S. history, behind only Hurricane Katrina in 2005. The storm center moved back offshore on August 28th, and then traveled up and made a second landfall on August 30th, 2017, near the Texas-Louisiana border. The effect of the storm surge and tide produced maximum levels of about 10 feet above ground level to the north and east of Harvey's center when it made landfall for the first time on the central Texas coast. This maximum storm surge levels were measured near Port Lavaca, which is in the upper reaches of Matagorda Bay. Tide levels in Matagorda Bay and San Antonio Bay and Aransas Bay were 1 to 2 meters above mean sea level when Harvey was making its impact, when it made its landfall for the first time. The landfall of Hurricane Harvey occurred on San Jose Island. This is northeast of Mustang Island on August 25th as a Category 4 storm. Despite the proximity to the landfall of a major hurricane, the beaches and dunes that are monitored by the Texas High School Coastal Monitoring Program students suffered minor impacts. There was very little dune erosion, and the beaches were basically cleaned off. They were lowered a little bit, but there wasn't the extensive beach and dune erosion that we expected on Mustang Island. Now, on San Jose Island, there was beach and dune erosion documented due to remote sensing techniques that were deployed following the landfall of Hurricane Harvey. On San Jose Island, there's also evidence of water flowing back out from the bay system. Remember that storm surge pushed higher into the bays than it was along the coast, and all that water had to return back into the Gulf of Mexico. And on San Jose Island, there are outflow channels cutting through the dune system and the beach and depositing sediment back out into the Gulf of Mexico. Now, the evidence for these being outflow channels and not washover channels created during the storm water pushing onto shore rather than this water was flowing back offshore after the hurricane had passed, is that you can see there's a little bend to the north of these outflow channels, these cuts through the dune system, and the sediment is being deposited back out in the Gulf of Mexico and not on the backside of the barrier island. Another piece of evidence are the barges, those red objects that are on the island. Those are barges that were secured in the Gulf Intercoastal Waterway during Hurricane Harvey, and they broke loose and they were pushed onto the barrier island and were caught up against the backside of the dunes as the water was flowing from the bays across the islands, trying to flow back into the Gulf of Mexico. Other areas that saw significant impacts from Hurricane Harvey and the water flow from the bays trying to get back to the Gulf of Mexico was in Port Aransas. These are images of the Port Aransas Nature Preserve. This is on the back side of the island. So you're looking at the Gulf Intercoastal Waterway. That's the water feature that you're seeing in these images. And then you have the low-lying barrier flat area of the island in these pictures. The image on the left is pre-Harvey, and the image on the lower right is post-Harvey. And the water flow, the power of the water created gaps or created breaches in the retaining wall that separates the Gulf Intercoastal Waterway from the barrier island and caused sediment flow onto these tidal flat areas on Mustang Island. Another piece of evidence showing the flow of water, the direction of water flow in this area was all the vegetation that was in this nature preserve was flattened and pointed in a Gulfward direction, indicating which direction the water was flowing across the island. Another area of significant damage was along the south jetty of Aransas Pass. This is the tidal inlet between San Jose Island to the north and Mustang Island to the south. The storm surge from the water being pushed out of Aransas Bay towards the Gulf of Mexico damaged the concrete jetty at this location and also created another outflow channel, another channel. The water was flowing across the jetty in this location and created this channel back out into the Gulf of Mexico. These images show the damage to the jetty. This was the water created by the water flow across the jetty and then out, and then the channel that was created out into the Gulf of Mexico. At the time these pictures were taken, riprap had been placed along the jetty to help support it, to keep it from collapsing. But the water was still draining from that channel back out into the Gulf of Mexico. Now, over time, sand that is out here on the beach, dry sand from the beaches and dunes will blow and fill in this channel, and it will heal this scar on the coastline. The 2020 hurricane season has been quite active in Texas. We have had 4 storms that have had an impact to the beaches and dunes and the cities and citizens that live along the Texas coast. First was Hannah that made landfall. This was in July 22nd through the 27th. It made landfall on Padre Island on July 25th. You can see the storm track. This storm actually formed in the Gulf of Mexico and traveled across in a westerly pattern across the Gulf of Mexico, making landfall just south of Corpus Christi. Some water level data from that storm, this is still preliminary, showed an increase of water level, the mean of a storm surge of about 4.5 feet above mean sea level in the upper reaches of Nueces Bay, Corpus Christi Bay. And the open coast tide gauge here at Bob Hall Pier showed a maximum water level of about 6 feet above mean sea level along the coast here. Bob Hall Pier was damaged from Hurricane Hannah. The end of the pier was washed away. This is a fishing pier in the Gulf of Mexico, but the equipment that was installed at the pier survived the storm and was still recording data. 3 other storms have had an impact, including a Category 4 Hurricane Laura that made landfall near that Texas-Louisiana border on August 27th. Tropic Storm Beta on September 21st in Matagorda Peninsula, and then Category 2 Hurricane Delta that made landfall on the Texas-Louisiana border on October 9th. For additional information about hurricanes, there's a lot of great resources out there, including the National Hurricane Center. That's where you can find forecasts, and there's information about hazards, how to prepare for hurricanes, what to do to evacuate, what you should have in your evacuation kit. And something else I want to mention is that the National Hurricane Center provided these Hurricanes at Home webinars earlier this year, and they're specific to different regions, but there is 2 that were recorded specifically for Texas, for the Texas region. And you can go to their YouTube channel and find these webinars. NOAA's hurricane pages are an excellent source of resources, including information and activities that you can do. The Earth Labs Hurricane Unit is an excellent resource for teachers and students, where you can do labs to determine where hurricanes form, how air pressure affects hurricanes. And then this Science and Society educational website is also another great resource with activities and information regarding hurricanes and their impacts on the societies. All of these resources that were mentioned on that last slide can be found by linking to our Zoomerama page. And I'm just going to go through some of these resources very quickly. The National Hurricane Center, this is where you can go and find current warnings, including Zeta. It's still a tropical storm as it's moving across the continental United States. It's retaining that status. You can find forecasts, graphics that have described it One of the graphics here is wind history. You can see where the hurricane force winds were compared to where the tropical storm force winds occurred, including they're still stretching up across North Carolina at this time. And then there's all kinds of educational resources and archives where you can go and find past storm activities, their tracks, see different tracks for different seasons. Let's really quickly, let's go to 2017. And we can, from here, you can look at the different storms that formed during that 2017 season, where they started and the tracks that they moved across the Atlantic Basin. You can also find information about the Pacific storms from this site as well. The NOAA's Resource Center has a great resource for hurricanes. There's lots of information about what is a hurricane, storm surge analysis, and you can also find different multimedia videos that you can look to see about hurricane webinars and storm surge videos. And one of those webinars was the one that I mentioned. This is the Hurricanes at Home. These are produced by hurricane specialists. They did these for middle school students, but they're great for anybody that wants to learn more about, any student that wants to learn more about hurricanes. So you get to talk to with actual National Hurricane Center specialists. These are the individuals that are forecasting these hurricanes and tracking them. So this is the one specifically for the state of Texas. But they also have Hurricanes at Home centered on how they impact like New England states and South Carolina and other parts of the United States coast. The Earth Labs Hurricane Unit has a teacher section and then also student pages where you can go to the labs and talking about hurricane anatomy, how they're tracked on the calendar, where they form, all about air pressure, and et cetera. So this is a great resource for both teachers and students looking for activities to do centered on hurricanes. And there's all kinds of earth science labs that are associated with this website. Hurricane and Society pages, it has information about hurricane science, observations that are made during hurricanes, and then some resources to be used by teachers and downloads that are great resources for teachers to use during to study hurricanes and their impacts on the United States coast. So I just want to thank you for joining us today. I hope you learned a little bit about hurricanes and how they impact coastal environments, and I'd be happy to take any questions.
Thank you, Tiffany. That is such a great overview of hurricanes. And you know, you mentioned the site where you could do a webinar with meteorologists, but as a coastal geologist, I think this is a great look into the work that you're doing. Now, I wondered if you could tell us a little bit about that high school coastal monitoring. Which high school students get to do that work with you?
Well, right now I have 8 schools that participate in the Texas High School Coastal Monitoring Program. And these stretch from High Island on Bolivar Peninsula down to Port Isabel High School, which monitor the beaches and dunes on South Padre Island. These are middle and high school students. I have one middle school that's involved in the program, and I take them on field trips 3 times a year, collecting beach monitoring data, showing them how to use instruments to collect data like GPS units, showing them how to conduct a beach profile where they measure the dune and the beach system, and then we compare that to data that has been collected over the past 20 years. This program is 20 years old, and we can see how these beaches and dunes have changed through time. And one reason this program is vital for the Texas coast is we have this continuation of data over a long time period, and we can see year-to-year changes, decade-to-decade changes, but we also can see storm impacts and the recovery, because if there is enough sand in the system, these beaches and dunes will recover following a hurricane. So the students that are involved in this program are collecting vital pre-storm data and then post-storm data. such as on Galveston Island with Hurricane Ike, both pre and post. And my Port Aransas students collected incredible data pre-storm and post-storm on Mustang Island following Hurricane Harvey.
That's fantastic. Earth processes are so dynamic. And I think when you live along a place like the coastline, sometimes you may not notice it but when a whole park gets covered up and you observe it is one thing, but sometimes it takes consistent, careful measurement over time to really be able to document how dynamic these processes are. And that's one reason I really think that what you're doing with the students is so important, especially because they live along the coast. This is part of their life.
Yeah, thank you.
But also, yes.
That's a great point to make. Every day, these beaches and dunes are changing. It's a dynamic environment. I think that term perfectly describes what is happening down there. The wind is constantly blowing. There's constant waves interacting along the shoreline. Sediment is moving from place to place, but you don't necessarily notice those day-to-day changes or even those year-to-year changes. And it takes a catastrophic event like a hurricane for people to recognize, oh, there's a big change here, or they notice a big change. And how do we live with what these changes might occur on these islands during these storms? It's very important to be prepared. It's very important to understand what may happen. And it's important to understand the hazards that are associated with these storms. What's the elevation of my house on this barrier island? I probably need to evacuate when there's a storm coming on shore.
Mm-hmm. Yes, and thank you so much. I really am very happy that you were able to join us in this Zoomerama series. And now I guess we'll thank you and say goodbye. Thank you. For those of you watching this on YouTube, if you have a question that we haven't answered yet, please leave a comment below and we'll do our best to get an answer to you. Also, check the description on the video links to more information on our website. And don't miss our next talk with Raymond Slade Jr. on water resources in Texas, issues and careers. It's live today at 2 p.m. Central Time and soon thereafter on YouTube. Thanks for watching. See you next time. Goodbye.